Fast-moving lava from Hawaii's Kilauea volcano forced new emergency evacuations overnight.
Right now, 1,700 people are still under a mandatory evacuation. The lava flow and toxic gas from volcanic vents are intensifying.
Since the turn of the millennium, the Earth has witnessed remarkable volcanic activity, from fiery eruptions in the Pacific Ring of Fire to disruptive ash plumes in far-flung regions. But what if a major catastrophe were to unfold in the heart of the modern world? The United States boasts no less than 169 active volcanoes, but surprisingly, the landscape has remained surprisingly tranquil. This quiet, however, belies the lurking potential of some of the nation's most dangerous volcanoes. Among these is the Mount Rainier, often overlooked, but one that can disrupt the lives of millions if it were to erupt. So why is Mount Rainier the United States' most dangerous volcano, and should we be scared? Let's answer just that, shall we? The volcano that keeps everyone awake at night. While Hawaii's lava-laden landscapes and Yellowstone's immense supervolcano often dominate headlines, and rightfully so, Mount Rainier is also equally deserving of attention. This marvel of nature casts an insidious shadow over the Pacific Northwest. Its towering, snow-capped peak is a symbol of natural beauty, but also a source of sleepless nights for many volcanologists. Unlike Hawaii's slow-moving lava flows, or Yellowstone's infrequent but apocalyptic potential, Mount Rainier is capable of causing sudden and widespread destruction. Jess Phoenix, a volcanologist and Union of Concerned Scientists ambassador, for instance, claims that Mount Rainier keeps her up at night because it poses such a great threat. So, how big of a threat is Mount Rainier really? And what will be the worst possible case if it erupts with all its might? An eruption of Mount Rainier would cause massive devastation, mostly due to lahars, which are rapidly moving torrents of water, rock, and debris. They form when an eruption rapidly melts the volcano's extensive ice and snow cover, flowing down valleys and drainage channels. Lahars grow in size and speed as they pick up debris, turning into a catastrophic slurry capable of obliterating everything in its path. What does this mean? The looming presence of Mount Rainier over communities like the Puyallup Valley and towns near Orting, Washington, amplifies this danger. What makes Mount Rainier so challenging is its height and the fact that it's cloaked in ice and snow. This means that even minor eruptive activity could release enough heat to trigger melting, sending torrents of water and debris barreling downhill. The speed and destruction would be unprecedented. Tens, if not hundreds of thousands of people could be impacted before they've had any time to react to the catastrophe. While Mount Rainier slumbers now, its history and scientific models make clear that it is only a matter of time before this sleeping giant stirs again. It's not alone either. Historical perspective. Major eruptions in United States history. The United States is a geological mosaic, home to some of the most captivating volcanic landscapes on Earth. Its diverse array of volcanoes stretches across the continent, from Alaska's remote Aleutian Islands to the verdant slopes of the Pacific Northwest and the fiery expanses of Hawaii. With 169 active volcanoes, the United States ranks as one of the most volcanically active nations. While many volcanoes slumber peacefully for centuries, their potential to erupt with catastrophic force makes them a constant focus of study and monitoring. Over the past century, several key eruptions have not only reshaped the landscape, but also left indelible marks on the collective memory and scientific understanding of volcanism. The most iconic of these volcanic events was the eruption of Mount St. Helens on May 18, 1980. A magnitude 5.1 earthquake triggered a massive landslide, the largest in recorded history, unloading pressure on the volcano and unleashing a lateral blast that flattened 230 square miles of forest in mere minutes. The eruption sent a towering ash plume 15 miles into the atmosphere, darkening skies and disrupting air travel across the region. 57 people lost their lives, and entire ecosystems were obliterated, leaving behind a surreal, otherworldly landscape. The eruption also dramatically reshaped the volcano itself, reducing its height by over 1,300 feet and forming a horseshoe-shaped crater. The 2018 Kilauea eruption was a slow, relentless force of destruction. Over several months, rivers of lava flowed from fissures in Hawaii's lower East Rift Zone, consuming nearly 700 homes and displacing thousands of residents. Entire neighborhoods were buried beneath molten rock, while new land was created along the coastline as lava poured into the ocean. The eruption dramatically altered Hawaii's landscape, adding nearly 875 acres of new land. But that's not all. Decades before Mount St. Helens' dramatic eruption, Lassen Peak in California offered a preview of volcanic potential in the Cascades. Beginning in 1914, the volcano experienced a series of minor eruptions, culminating in a powerful blast on May 22, 1915. This eruption produced pyroclastic flows, avalanches of hot gas and rock that scorched nearby valleys, and a towering ash plume visible as far as 200 miles away. Fortunately though, the largest volcanic eruption of the 20th century occurred in one of the most remote regions of Alaska. However, its impact was felt worldwide. Over the course of 3 days in June 1912, Nova Rupta erupted with such intensity that it expelled 30 times more magma than Mount St. Helens in 1980. The eruption created the Valley of 10,000 Smokes, a surreal landscape of ash-filled valleys and steaming fissures. The ash cloud rising from the eruption affected weather patterns and reduced temperatures. Each of these events has expanded our understanding of how volcanoes operate and how they shape the world around them. As scientists continue to monitor these geological giants, their work ensures that the lessons of the past guide us toward a safer future. Speaking of geological giants, let's not forget the fiercest of all. The most dangerous volcano in the United States. Mount Rainier, a towering sentinel in the Cascade Range, stands as the tallest peak in Washington state and one of the most iconic landmarks in the Pacific Northwest, rising to an elevation of 14,410 feet, or 4,392 meters at Columbia Crest. The mountain is an awe-inspiring spectacle that defines the southeastern horizon of the Seattle-Tacoma metropolitan area. Remarkably, the mountain can be glimpsed from as far away as Mary's Peak in Oregon and the North Shore Mountains of British Columbia. The volcano is not just a visual marvel, it is also a geologic and hydrologic powerhouse. It boasts 26 major glaciers and 36 square miles, or 93 square kilometers of permanent snowfields, making it the most heavily glaciated peak in the contiguous United States. This extensive glaciation feeds numerous rivers, including the Carbon, Cowlitz, Nisqually, and Puyallup, each originating from eponymous glaciers. These waterways sustain the region's ecosystems and communities, eventually flowing into Puget Sound, the Columbia River, and Commencement Bay. The mountain's summit is crowned by 2 overlapping volcanic craters, each exceeding 1,000 feet, or 300 meters in diameter. These craters are fascinating not only for their size, but also for the geothermal activity that keeps sections of the crater rims free of ice and snow. This heat has sculpted the world's largest volcanic glacier cave system, with nearly 2 miles or 3.2 kilometers of winding passages within the craters. Hidden beneath over 100 feet or 30 meters of ice in the West Crater lies North America's highest crater lake, a small, frigid body of water that is accessible only through these caves. Mount Rainier's broad summit plateau features 3 named summits: Columbia Crest, Point Success, and Liberty Cap. On the eastern flank, Little Tahoma Peak is an eroded remnant of Mount Rainier's ancient higher form. If viewed independently, Little Tahoma would be the 3rd highest peak in Washington state. Beyond its physical attributes, Mount Rainier represents the dynamic interplay between geology, climate, and ecology. As both a towering beauty and a potential hazard due to its volcanic nature, it remains a focus of admiration and study. Its snow-capped summit and cascading glaciers embody the Pacific Northwest's natural majesty, while its glacial rivers sustain life across the region. Truly, Mount Rainier is a geological masterpiece and a vital cornerstone of Washington's natural heritage. But don't let the visual vistas fool you. Understanding the threat. Mount Rainier is a stratovolcano, which means that its formation is marked by layers of lava flows, pyroclastic deposits, and debris flows that trace its history back more than 840,000 years. These early deposits, known as the Lily Formation, represent a proto-Rainier, or ancestral volcanic cone, that predates the present-day structure. The current cone, formed through successive eruptions, is estimated to be more than 500,000 years old. The mountain's composition primarily consists of andesite, a volcanic rock. Glaciers carved deep into its flanks, accentuating its rugged and heavily eroded appearance. Mount Rainier likely once soared to an elevation of approximately 16,000 feet, or 4,900 meters. However, a catastrophic debris avalanche around 5,000 years ago drastically reshaped its profile. This massive collapse, known as the Osceola mudflow, reduced the volcano's height by about 1,600 feet, or 500 meters, leaving it at its current elevation. The mudflow, a mixture of volcanic debris and melted glacial ice, cascaded over 30 miles or 48 kilometers to reach what is now Tacoma and southern Seattle. Rainier's history is punctuated by significant events of erosion and volcanic renewal. The Osceola mudflow represents one of the most dramatic episodes in the mountain's history, but it was not the last. Around 530 to 550 years ago, the electron mudflow occurred, though on a smaller scale. These lahars, fueled by the abundant glacial ice on Rainier's slopes, demonstrate how the volcano can unleash devastating flows capable of transforming landscapes far beyond its immediate vicinity. Following the Osceola mudflow, Mount Rainier underwent a period of reconstruction. Eruptions of lava and tephra began rebuilding the summit cone. The interplay of explosive eruptions, glacial sculpting, and catastrophic lahars makes Mount Rainier not only a majestic natural landmark, but also a dynamic and potentially hazardous feature of the Pacific Northwest. Seismologists record up to 5 earthquakes per month near the summit, with occasional swarms of 5 to 10 shallow tremors occurring over a span of 2 to 3 days. These seismic events, concentrated roughly 13,000 feet or 4 kilometers below the summit, are believed to result from the circulation of hot fluids beneath the volcano, which are responsible for the hot springs and steam vents scattered throughout Mount Rainier National Park. Significant seismic swarms at Mount Rainier have been documented in 2002, 2004, 2007, 2009, 2011, and most recently in 2021. Glaciers are also among Mount Rainier's most prominent and transformative features, shaping the landscape and sustaining river systems that provide water for hydroelectric power and agriculture. These glaciers flow under the force of gravity, moving through a combination of basal sliding and internal deformation. The size and extent of Mount Rainier's glaciers have fluctuated significantly over millennia. During the last ice age, from approximately 25,000 to 15,000 years ago, glaciers blanketed most of the area now within Mount Rainier National Park and extended into the Puget Sound Basin. A more recent glacial advance occurred during the Little Ice Age, between the 14th century and 1850, when glaciers reached their farthest extent down valley since the last ice age. For instance, the Nisqually Glacier advanced 650 to 800 feet, or 200 to 240 meters beyond the current glacier bridge site, while other glaciers, such as Tahoma and Emmons, exhibited similar growth. Between the peak of the Little Ice Age and 1950, these glaciers lost approximately 1/4 of their length. A brief period of advancement occurred from 1950 through the early 1980s due to cooler mid-century temperatures and high snowfalls in the 1960s and 70s. Notably, the Carbon, Cowlitz, Emmons, and Nisqually glaciers advanced during this time, although their overall volume continued to decline. Since the early 1980s, most of Mount Rainier's glaciers have been thinning and retreating in response to a warming climate. Recent studies highlight significant glacial loss between 2015 and 2022, prompting researchers to remove Stevens Glacier, along with the Pyramid and Van Trump glaciers, from the inventory of active glaciers due to their dwindling size. These declines have serious implications, as Mount Rainier's glaciers are not only vital sources of water, but also pose a hazard. Glacial outburst floods have been documented, such as the 30 floods from South Tahoma Glacier during the 80s and early 90s, and another in August 2015. So how bad can it get when Mount Rainier erupts? Well, we can take a peek at history for some answers. History of the killer volcano. Mount Rainier has been a significant cultural, historical, and natural landmark for thousands of years, attracting the attention of indigenous peoples, explorers, and modern visitors alike. For indigenous tribes such as the Nisqually Indian tribe, the Cowlitz Indian tribe, the Confederated tribes and bands of the Yakima Nation, the Puyallup tribe of Indians, and the Muckleshoot Indian tribe, the mountain and its surrounding landscapes were central to their way of life. These tribes utilized the mountain's forests and alpine meadows for seasonal hunting and gathering, relying on its abundant resources during the short summer months. Archaeological evidence suggests that humans have been engaging with the area for over 8,500 years. European exploration of the Pacific Northwest began with the Spanish in the late 18th century, as expeditions under Juan Pérez and Juan Francisco de la Bodega y Cuadra charted the region's coastline. English explorers, including Sir Francis Drake in 1579 and Captain James Cook in 1778, laid competing claims to the region. These efforts were followed by fur traders like Sir Alexander Mackenzie and American expeditions, including the famous Lewis and Clark expedition, which documented Mount Rainier in 1806. Captain George Vancouver formally named the peak Mount Rainier in 1792 in honor of Rear Admiral Peter Rainier during his explorations of the region's waterways. As the 19th century progressed, Mount Rainier became a focal point of territorial claims among Spain, Russia, the United States, and Britain. Treaties like the Oregon Treaty of 1846 ultimately settled disputes, establishing the US as the primary governing authority in the region. During this period, explorers and naturalists began to delve into the mountain's environment. William Fraser Ptolemy ventured into its forests in 1833 to gather medicinal plants. Later, mountaineers Hazard Stevens and P.B. Van Trump achieved the first recorded summit in 1870, marking the beginning of a storied history of alpine exploration. Fay Fuller, in 1890, became the first woman to reach the summit. The mountain's natural springs and scenic beauty soon attracted visitors, notably James Longmire, who discovered mineral springs in 1883. Longmire established a spa and hotel that served as a gateway for tourism, eventually becoming the park's headquarters before relocating to Ashford due to flooding. Today, Longmire remains one of the most visited areas in Mount Rainier National Park. Advocates like John Muir championed the preservation of Mount Rainier, and in 1899, President William McKinley designated it as Mount Rainier National Park, the fifth national park in the United States. The park was created to safeguard its natural wonders, timber and watersheds, while offering public enjoyment. This designation spurred infrastructure developments to accommodate visitors, supported by railroads and local businesses eager to capitalize on the mountain's appeal. Mount Rainier has appeared on United States postage stamps, including a 1934 National Park issue and the Washington State Quarter released in 2007, which features the mountain alongside a salmon. This enduring image reflects Mount Rainier's deep connection to Washington State's identity. Geologically, the mountain remains an active volcano, prompting the establishment of the Mount Rainier Volcano Lahar Warning System in 1998. This system, managed by Pierce County Emergency Management, aims to protect nearby communities like Tacoma, Puyallup, and Orting from potential volcanic hazards. The most recent confirmed eruptive activity occurred between 1820 and 1854, though unverified accounts of eruptions extend into the late 19th century, with reports in 1858, 1870, 1879, 1882, and 1894. Interestingly, the Smithsonian Institution lists the last significant eruption at Rainier around 1450. This dormant phase has not diminished its potential threat, prompting the installation of seismic monitors in Mount Rainier National Park to track ground movements and provide early warnings of volcanic activity. An eruption of Mount Rainier could have catastrophic consequences, with ash fallout potentially affecting areas as far as Vancouver, British Columbia, and San Francisco, California. Its location on the eastern rim of the Pacific Ring of Fire places it within a geologically volatile region. The Ring of Fire's history of violent eruptions, such as the 1980 Mount St. Helens eruption, highlights the magnitude of hazards associated with volcanic activity in this arc. Statistically, the Cascade Range, which includes Mount Rainier, sees 2 to 3 significant eruptions per century. Mount Rainier's potential for destruction is amplified by its designation as a decade volcano, a classification given to the most hazardous volcanoes worldwide due to their potential for significant loss of life and property. Compared to Mount St. Helens, Mount Rainier has a greater volume of glacial ice, which would exacerbate the destructive power of lahars. Lahars pose the greatest threat to surrounding communities, with approximately 150,000 residents currently living atop historical lahar deposits. The Osceola mudflow, which occurred around 5,000 years ago, serves as a grim precedent, as a similar event today could obliterate towns such as Enumclaw, Orting, Kent, and Auburn, with its reach extending into downtown Seattle and potentially triggering tsunamis in Puget Sound. Lahars are not the only threat. Pyroclastic flows and lava could also devastate the region, while the weakening of the volcano's structure, due to hydrothermal activity, adds another layer of unpredictability. The economic consequences of a significant eruption or lahar are staggering, with estimates suggesting up to $40 billion in damage. Despite this, many residents remain unaware of the risks, as only a few carry appropriate flood insurance or preparedness measures. Neighboring King County, despite being in the hazard zone, lacks zoning restrictions related to volcanic risk, leaving many areas vulnerable. Funding for lahar protection has also decreased in recent decades, raising concerns about readiness. Local authorities have addressed these concerns by conducting large-scale annual evacuation drills involving schools and communities. The 2024 exercise, which included 45,000 students and staff from multiple school districts, demonstrated the seriousness with which the region approaches preparedness. Emergency operations centers were activated to streamline evacuation processes, emphasizing coordination between municipal, educational, and emergency services. But we're not done with the story of the killer mountain. Mountaineering accidents. Mount Rainier, with its towering summit and immense glaciers, presents a formidable challenge to mountaineers, drawing thousands of climbers each year despite its significant demands. The climb is regarded as one of the most technical and strenuous in the contiguous United States, requiring not only physical endurance, but also expertise in glacier navigation, crevasse rescue, and technical climbing. Each year, between 10,000 and 11,000 climbers attempt to summit the peak, but only about half of these succeed. Weather conditions, such as sudden storms, whiteouts, and high winds, combined with the rigorous physical demands of the climb, are the most common reasons for failure. Summiting Mount Rainier typically requires a 2 to 3 day expedition. It is a proving ground for mountaineers aspiring to tackle the world's highest peaks. Its glacial environment offers a microcosm of conditions found in the Great Mountains of Alaska or the Himalayas, making it a popular training destination for expeditions. However, Mount Rainier's challenges demand thorough preparation, proper equipment, and a deep respect for the mountain's unpredictable nature. Climbers must also adhere to strict regulations, including obtaining climbing permits and adhering to leave-no-trace principles, to protect the mountain's fragile ecosystem. Despite its challenges, Mount Rainier continues to captivate adventurers with its majestic beauty and the sense of accomplishment it bestows on those who conquer its peak. However, its history is also marked by a series of mountaineering accidents. From its first recorded climbing fatality in 1897 to more recent tragedies, the mountain has claimed numerous lives, reminding climbers of the unforgiving conditions they may face. On average, Mount Rainier sees about 2 mountaineering-related deaths each year. These fatalities often result from falls, avalanches, rock and ice falls, or hypothermia, typically exacerbated by factors such as high-altitude exposure, extreme fatigue, dehydration, or sudden shifts in weather conditions. Between 1897 and 2011, 89 mountaineering deaths were officially recorded on Mount Rainier. The mountain accounts for roughly 7% of all mountaineering deaths and 6% of mountaineering accidents in the United States. The first recorded death on Mount Rainier was that of Edgar McClure, a University of Oregon chemistry professor, on July 27, 1897. McClure, descending the mountain after sunset, inadvertently stepped off a rocky edge in the darkness, falling to his death. The site of this tragedy, now known as McClure Rock, serves as a solemn reminder of the mountain's hazards and the importance of caution during climbs. One of the deadliest single incidents on Mount Rainier occurred in 1981 on the Ingraham Glacier, where an avalanche or icefall claimed the lives of 10 climbers. This tragedy remains the worst mountaineering accident in the mountain's history. Similarly, the 2014 Liberty Ridge disaster ranks among the most harrowing incidents in recent memory. On May 31st, 6 climbers fell approximately 3,300 feet while attempting to summit via the challenging Liberty Ridge route. After the climbers failed to return, search operations detected avalanche beacon signals, leading to the grim conclusion that there was no chance of survival. Evidence, including a debris field littered with clothing, tents, and ice fragments at 9,500 feet, suggested a possible avalanche or slide. though the exact cause remains unclear. The bodies of 3 climbers were located during a training flight in August 2014 and were subsequently recovered. However, the remains of the remaining guide and 2 clients were never found, likely buried under tons of ice and rock. The mountain's most infamous aviation-related disaster occurred in 1946 when a plane crashed on the South Tahoma Glacier, killing all 32 people on board. But what if death were to descend from the peak and engulf nearby residents? What would a future eruption look like? A future eruption of Mount Rainier would likely be a catastrophic event, with the potential to release pyroclastic flows, lava, and ash clouds that could blanket large areas of surrounding communities. As one of the most active and dangerous volcanoes in the United States, Mount Rainier's eruptions often include explosive activity, sending ash plumes high into the atmosphere and causing ashfall as far as hundreds of miles from the summit. The eruption would significantly disrupt air traffic, contaminate water sources, and cause widespread damage to infrastructure. The lava flows, while likely not as fast or extensive as other volcanoes, would still cause destruction to roads and buildings. The eruption would also trigger the formation of lahars, or volcanic mudflows, which would be one of the most destructive aspects of the eruption. The intense heat from the eruption would rapidly melt the mountain's snow and glaciers, sending large volumes of water mixed with volcanic ash, rock, and debris down the river valleys surrounding the mountain. Lahars, which can travel at speeds of up to 60 miles per hour, would flow down rivers like the Puyallup, Carbon, and White Rivers, impacting communities such as Orting, Sumner, and Tacoma. These mudflows can bury towns, destroy bridges, and wreak havoc on infrastructure, posing a severe risk to human life and property. The long-lasting effects of lahars would reshape the landscape, flooding low-lying areas and leaving a path of devastation in their wake. These fast-moving lahars can easily bury entire communities, making them one of the most lethal hazards associated with volcanic activity. The eruption of Colombia's Nevado del Ruiz in 1985 serves as a tragic and sobering example of the catastrophic impact of lahars. After a relatively modest eruption, a massive lahar, formed by melted snow and ice mixing with volcanic ash, rapidly descended on the town of Armero. In just a few hours, it obliterated the town, claiming over 23,000 lives, and burying everything in its path under a thick layer of volcanic mud and debris. When considering Mount Rainier's potential for producing lahars, the risk becomes even more alarming. Rainier is covered by vast glaciers and snowfields, and it has about 8 times the volume of ice and snow that Nevado del Ruiz had when it erupted. The geological history of Mount Rainier reveals that it has experienced multiple lahars over the past 6,000 years, with at least 11 significant mudflows reaching the surrounding Puget lowlands. These lahars have been triggered both by volcanic eruptions and by landslides that destabilized large portions of the mountain. Some of the largest lahars occurred as a result of volcanic eruptions that melted the glaciers, sending torrents of water, ash, and rock into the surrounding valleys. However, even more concerning is the possibility of landslide-triggered lahars, which pose a unique danger. The west flank of Mount Rainier is home to large sections of weak, fractured rock, which could collapse into the valleys below, triggering another catastrophic lahar event. These types of lahars are particularly difficult to predict, as they are not always linked to volcanic activity, but are influenced by factors such as rainfall, seismic activity, and the stability of the mountain's slopes. Should a lahar form during a future eruption or landslide, it could easily travel to surrounding communities within minutes. For example, a lahar generated by a volcanic eruption could reach the nearby town of Orting, located just 10 miles from the mountain, within just 10 minutes. Larger cities like Tacoma or Seattle, located 60 miles away, could still be at risk within an hour of the eruption, depending on the volume and speed of the mudflow. This incredibly short time window for evacuation makes it crucial for local authorities to be prepared, as even a small delay in the evacuation process could result in significant loss of life. In addition to the immediate loss of life and destruction of infrastructure, lahars from Mount Rainier could have long-term environmental and economic impacts. The rivers and streams surrounding the mountain could be choked with debris, blocking transportation routes and water supplies for extended periods. The heavy deposition of ash and volcanic materials could permanently alter ecosystems, including forests, farmland, and wildlife habitats. The region's economy which depends heavily on agriculture, tourism, and transportation, could be devastated by the widespread destruction of infrastructure and the disruption of local economies. Furthermore, the threat of lahars would require costly mitigation efforts, including the construction of barriers, evacuation routes, and the continued monitoring of the mountain's activity. Given the potential for rapid, catastrophic lahar events, Mount Rainier remains one of the most closely monitored and studied volcanoes in the United States. The worst-case scenario for Mount Rainier is centered around a massive lahar of 260 million cubic meters of debris, which would be 4 meters deep as it begins its descent from the west side of the mountain. To put this in perspective, this volume of debris is equivalent to 104,000 Olympic-sized swimming pools. Once unleashed, the lahar would travel with terrifying speed, reaching the lowlands of Orting, Washington, within approximately an hour after the eruption. The communities in its path will have little time to respond. Another area of concern is the Nisqually River Valley. This valley, which lies to the southeast of Mount Rainier, has the potential to experience an even more catastrophic event if a massive lahar were to displace enough water from Alder Lake. Alder Lake sits in a precarious position behind the Alder Dam, which towers at 100 meters or 330 feet in height. Should a lahar inundate the lake, it could cause the dam to spill over, potentially unleashing a flood that would exacerbate the already disastrous situation. The dam's failure could result in widespread flooding that would not only compound the damage caused by the lahar, but also pose a direct risk to communities located downstream. While Mount Rainier's eruptions may be rare, the potential consequences of a massive lahar event are profound. The urgency of preparedness for both eruptions and lahar-triggered landslides is beyond vital. With populations growing in the surrounding areas, the need for early warning systems, education, and rapid response protocols is greater than ever. The lessons learned from past eruptions and from large-scale drills will be critical in saving lives and mitigating damage if Mount Rainier erupts. The combination of advanced detection systems, public education, and effective response plans will be the key to ensuring that communities are as prepared as possible for the potential dangers posed by one of the most dangerous volcanoes in the Pacific Northwest. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.